I'll just revise what we looked at yesterday. So when we are looking at the electrolysis of molten salts, the salt cannot conduct electricity in the solid state, so heat must be applied first, and then when the salt is in the molten state, then you can pass electricity through it, and then a chemical reaction will take place. So what will happen is that the cations will move to the cathode. So positive ions will move to the negative electrode. Positive ions will move to the negative electrode, and the negative ions will move to the positive electrode. This is the main idea about the operation of the cell that will help you to understand the electrolysis of molten salts. So when the electrolyte is actually the molten salt, all right? And as you can see from this diagram, heat energy will be applied first, and then electrical energy will be passed through. So for molten salts, and the example here is sodium chloride. Sodium chloride is NaCl, and because it is molten, there are only two ions that are there. That's Na plus and Cl minus. Can you see what I'm writing? Yes?
Yes, Mr.
All right.
Yes.
So which ion will go to the cathode, Na plus or Cl minus? Which ion will go to the cathode?
Na. Yeah. Sodium, Mr.
All right. So sodium will go to the cathode because sodium is the positive ion, and it will go to the cathode, which is the negative electrode. Chlorine will go to the anode. All right. So like what I said yesterday, first of all, you identify which ion will go to which electrode, and then you write the half equation. And when you write the half equation, it will show you it will tell you which product will be formed. These are the three main questions that are asked in the exam. And all right, so for this example about the molten sodium chloride, the keyword here is molten. To differentiate between whether the question is about molten salt or aqueous salt, these two words will always be used. So if the question says talks about the electrolysis of molten, you must know that molten salts involves two ions only. All right. So at the anode, for this example, the N ion will move. All right. So we will start the half equation with the ion. So Cl minus, it will be attracted to the anode, and oxidation occurs at the anode. So Cl minus will be oxidized at the anode. All right. And remember, oxidation, the plus sign is on the product side. All right. But the equation has to be, the charges have to be balanced, or the oxidation numbers have to be balanced. Huh? The left side has to be the same as the right hand side. And so, but chlorine also exists as a molecule. So if you write 2 here, we'll also write 2 there, and we put 2 electrons. All right. So that will be the half equation at the anode. What is the product? From the equation, what will be the product? Anyone? Right?
Chlorine.
Yes. Another question that you'll be asked, command be asked, is to identify the product. So in the exam, if you're asked to identify the product, if you are writing the formula, write Cl2. Do not write Cl. All right? For Cl is the atom. Cl2 is the pair. If you want to spell it out, make sure the spelling is correct and write chlorine gas. All right? Let's go to the cathode. So the cation is the positive ion, and it will move to the cathode. All right? Please note that for molten salts, both have equation. They start with the ion. So Na plus will move to the cathode and it will be reduced. And reduction is the gaining of electrons, so the plus sign should be on the reactant side. So Na plus electron will give you Na. All right? So that's the half equation, and the product will be sodium metal. All right? So we've identified which ion will move to which electrode. We've written the half equation, and we've identified the product. Do you have any questions so far?
No.
The simplest of the questions in the exam is identifying the product. So I'll let you talk about I'll let you try to use these solves to tell me the products and work out something that will help you to identify the products easily. You can see that the first example is calcium chloride. Remember, there are only two ions. All right? What are the two ions here for molten calcium chloride? What are the two ions?
Calcium and chlorine.
What are the two ions?
Calcium and
Calcium and chlorine.
Can you tell me the charges too? What are the charges?
2 plus.
Ca 2 plus and Cl minus.
Which one
Minus.
is the cathode?
Sorry.
Which ion will go to the cathode?
Calcium.
Correct? That's correct. And which will go to the anode?
Chloride.
All right. And what will be the product?
Calcium chloride.
No. What will be the product
No.
at the cathode?
No.
Cathode?
Calcium.
You might.
Is it like calcium solid
Yes. Calcium
at the cathode?
at the
It's a
cathode,
solid
and at
gas.
the anode will be chlorine.
Chlorine gas.
And
Oh.
some of you might make the mistake, and instead of saying calcium, you will say calcium 2 plus is the product. No. When you are writing the formula, calcium is just Ca. Do not write Ca2 plus. Differentiate between these. If the question is asking you about the ion that will move to the electrode, for example, which ion will move to the cathode, your answer will be calcium. Sorry, calcium 2 plus. But if it asks for the product, then it's just calcium. Am I clear?
Yes, Mr.
All right.
Yes.
Anyone having problem with half equation? Let me try to write all the half equations for each of these examples, and you can see what we're supposed to do. All right. So for the first one, calcium ion is going to move to the cathode, and reduction occurs at the cathode. So your half equation will be Ca2 plus 2E will give you Ca, and chlorine is going to go to the anode. So you will get 2Cl minus will give you Cl2 plus 2E. So this is the half equation. These are the products. Again, these are the questions that are asked in the exam. For the second one, sodium is going, Na plus is going to move to the cathode. So the half equation will be Na plus electron will give you Na. And iodine is going to move to the anode. So I minus, it's 2I minus plus I2 will give you 2 or plus 2E, sorry. So your products are sodium and iodine. And the last one is lead. So lead is also going to Pb2 plus, lead 2 plus will move to the cathode, and it will be reduced to form lead solid, molten lead, and you got to be careful with oxygen. 2O2 minus will give you O2 plus 4 electron. So these are the half equation. It gets complicated when we look at aqueous salts. All right. I have 15 more minutes to go. I'd like to start on electrolysis of aqueous salts. I gave some worksheets. I gave a handout with questions to practice on the electrolysis of molten salts. You try to work on those and please come up with questions. When I answer your questions, you are going to learn. Any questions on electrolysis of molten salts? Can I move on?
Yes.
Yes.
All right.
Mr.
Yes.
No, Mr. In the exam, will there like be a table similar to this, or they'll just give us like a,
There are different kinds of questions. In fact, one of the exam questions in the 2014 paper is actually like the table I have with you. I mean, I have shown you there. So it's how easy the question is. I mean, it's this topic is simple. They can just put the salts and ask you to name the product. Or the most difficult question will be writing the half equation. So what I'm going through are actually the kind of questions that I saw, and I'm directing the teaching towards it. Shall we?
Yes.
All right, thank you. Now, the difficulty with the electrolysis of aqueous salts is that water is involved. For molten salts, it's only the pure salt and heat is applied, so it separates into the two ions. But for aqueous salts, water is also there. So you will have the ions for the salt, like NaCl, NaCl-AQ. The problem with NaCl-AQ making it difficult for electrolysis is that there is Na plus, there is Cl minus from the salt, but because it's dissolved in water, you also have OH minus from water and H plus. So you will now be heavy, you will be presented with two ions at each electrode. So which one are you going to choose? Or which ion will be discharged at each electrode now that you have two at each? That is the difficult part of this. All right? Otherwise, what you are supposed to know for electrolysis of molten salts, again, you have to describe the setup and operation of the cell. That's similar to molten salts, but it's just that for molten salts, the electrolyte is the molten salt or the salt that has been melted. But for aqueous salts, the electrolyte is the salt that is dissolved in water. That's the only difference. Otherwise, electron flow, movement of ions, all of these are still the same as molten salt. It's just applying the idea of electrolytic cells. And again, the main questions that appear in the exam are for you to identify the products at the anode and at the cathode, and you are going to write half equations as well. So these are the main questions. All right. Now, always study the electrolytic cell from time to time, so you will master the concepts about electrolytic cell. Again, cation will move to the cathode, so cat. cat is positive, cat ions is positive, but cathode is negative, and anion is negative, but anode is positive. NN, cat, cat. Something you can use to memorize. All right? Now, the electrolysis of aqueous salts is usually used to extract gases. All right? So we can pass electricity to water, and then water will separate into hydrogen and oxygen, and we can collect the gases. So the application of the electrolysis of aqueous salts is to collect, can be used to collect gases. All right? Now, let's look at one example so that you will understand what I'm saying. Okay. Now, when we look at the electrolysis of aqueous sodium chloride, with aqueous salts, there are two types of questions. You can have questions about dilute aqueous salt or concentrated, and the questions slightly differ. All right. Like I said earlier on, there are now 4 ions involved. 4 ions that you are going to choose, 2 at each electrode. All right. And this is how you are going to select the ion which will be discharged at each electrode. All right. Let's look at cathode first. And remember, cat ions go to the cathode. All right. Let's look at this one here. Now for cathode, the rule is the more reactive, the more the reactive the element is, the more stable its ion will be. All right. So the more reactive element, the ion of the more reactive element will remain in solution, and the ion of the less reactive element will come out of the solution. Are you with me?
Yes, Mr.
All right. So for example, let's look at Cu2 plus and K plus. Cu2 plus and K plus. Which of these two elements is more reactive? Potassium or copper? It's a giveaway one. Potassium is one, more reactive. So potassium will remain in solution and copper will come out. That's the idea when you are trying to decide which ion will move to the cathode. All right? Is that clear?
Yes.
Okay.
Yes,
Now,
yes.
Now let's do the first one. Let's go to this. And I've written the rule here. The more reactive a metal is, the more stable its ion will be, and the less chance it will be discharged, meaning that it will move towards the electrode. So let's look at NaCl. This is the cathode. So at the cathode, Na plus and H plus will move. Na plus and H plus will move. Which is more reactive, sodium or hydrogen? Which is more reactive?
Hydrogen.
No. Which is more reactive?
Sodium.
So sodium will remain in solution. Sodium is more reactive, so its ion will stay in solution, and the ion that will move to the cathode will be the less reactive one, so hydrogen will move. And this is hydrogen will move, and what will be the product? The product will be hydrogen gas, and you have to write this half equation.
Hydrogen gas.
All right. So for the cathode, the more reactive element, the ion of the more reactive element stays back in the solution, and the ion of the less reactive element is the one that will be discharged and forms the product. Any questions? It's straightforward. Let's look at the anode and we will stop from there. At the anode, this time you have the anion, so you have OH minus. For this example, you have OH minus and you have Cl minus. All right. For the cation, it is easy because you are looking at the reactivity. But for the anion, I'd like you got to memorize this one here. For the anion, you got to memorize this one. Hydroxide is the least stable, so it will come out, and sulfate is the most stable. All right? But from our example, from NaCl, we are dealing with OH minus and Cl minus. So which one is more stable? Cl minus is more stable, all right? So Cl minus will here. We have Cl minus and we have OH minus. So Cl minus is more stable, it will remain in solution, and OH minus will be discharged. And this is the half equation. And we can work that out with the method of balancing half reactions, which you did at last term, or towards the beginning of this term. So you will write this lengthy equation, half equation here, and the product will be, the main product is oxygen gas. All right? I'll solve one or two exam questions and we will stop. This is a 2001 question. All right. An acidic solution of copper sulfate is electrolyzed using 2 platinum electrodes. What is the product at the anode? Do not say platinum. Platinum is unreactive. It will not react. What will be the product?
Oxygen.
Oxygen gas.
Correct. Oxygen is the answer. Let's try another one. No, let's leave this one. Let's find a dilute. You tell me the products to speed up. What will be the product at the cathode? For this one, at the cathode,
Sodium.
Na plus and H plus will go. So Na plus is more reactive, it will stay, so the product will be hydrogen.
Oh.
And this one, you will have OH minus and Cl minus. Cl minus is more stable, it will stay. OH will go, so the product will be oxygen.
Oxygen gas.
I will let you try some questions and I'll explain further when we meet the next time. Now, if you have any questions, you can message me or you can send an email and I will be ready to help you. All right, 12 hours. Thank you very much.